All right, let me try that again. I was getting an echo. I'm assuming everybody else probably was too. Um, I'm streaming from home, which is what I normally do, but I also normally bring my work laptop home to do this. And I didn't today or yesterday when I came home for the weekend, so I kind of had to set up on my home laptop. And yeah, so sorry about the weird little um, kind of echo happening there for a minute. And so, anyway, um, yesterday I was working with someone on Discord. Literally, their name was someone. And we were working on, they wanted to make a two-piece MDF door. And they had some code going on, and they asked a few questions and we worked through it. But after we resolved their initial sort of issue, they wondered how to basically create grooves. Going to pull this up real quick. So basically, we kind of worked through some things, right? And then they were wondering if they could basically create a UCS on a door to create a bunch of vertical grooves, right? And this particular person is using Perry Miller's UCS for grooves, which I don't have any like issues with Perry's UCS. I think it's great, but in this particular case, the user was they had to shape constrain their flat panel that was going to go into their shaker door because their 3/8 router bit that does the rabbet on the back side of the door would leave a 3/8 radius in the corners, and so they wanted to shape the flat panel insert on the corners to match the inside radius of their tool. So to do that, we had to do some shape constraining and then save it as a library part. And um, so adding routes like this to a part that is being dimmed by a UCS is, well, basically, as much as I can remember, because I haven't really done something like that in a while, but basically you have to dim the routes and then you have to owner them to the UCS added part. Otherwise, it just doesn't work. When you try to dim operations to a part that was dimmed by a UCS, there's just some hoops to jump through. And so not only not only was that kind of like a bummer for them because they couldn't just use Perry's UCS, but they also were not familiar with writing loops. And after talking with Tristan a little bit about it yesterday, because he was kind of hanging out in the chat with us while we worked through it, I just decided to try to stream for a little bit today and give a very simple introductory sort of lesson on writing a loop. Um, Loops for me are something that were very, very difficult to learn, as anybody who spends time talking with me has probably heard me say, and might even be tired of hearing me say. But I don't really know why it was so hard for me to grasp, but I know that it was. And I think that it's just a concept that is very abstract. And because of the abstract nature of the concept, I think it's just a challenge. And so I can't promise that I'm going to be able to really clarify anything for anyone here, but I'm going to do my best. And I'm going to try to approach this a couple of different ways. First, I'm going to try to just kind of explain it in my own words, which will most likely be kind of confusing. And then I am actually going to see what ChatGPT has to say about, explaining a loop to somebody who doesn't really understand it, or explaining the concept in general. And maybe, my sort of very simple explanation in tandem with what ChatGPT has to say, maybe that will be what it takes. But basically, um, when you're looping through, when you're creating a loop with any type of programming language, you're basically creating dynamic um, a dynamic set of code that can do exactly the number of actions required by the circumstances that exist, which can always be different. So basically, when we want to just add like one route to a part, we're just saying, for each adjustable shelf, dim a route, right? And then every adjustable shelf in your job will get that route. And if you wanted to dim two routes, you would have to, write the block of code twice. But if you wanted to write something that says, if my shelf is 24 inches long, I want to put a 1 inch wide by 3/8 inch deep dado spaced out equally over the entire length of that part, that starts to become a lot more difficult to do, because your shelves are going to be all different lengths. Presumably, right? You might just have 50 cabinets in a job and they're all the exact same thing. But generally speaking, when we're building, we're working with all sorts of different sizes. If you're in a custom mill workshop, custom case workshop, whatever you work for. And so basically, the loop allows you to dynamically tackle those different things that you might run into where there isn't a set solution. There are a lot of variables that exist. And yeah, it's a smart way to code, and it cuts down on the amount of work that it takes. So anyway, now that I've kind of rambled through my very elementary explanation, there's one other kind of example that I'd like to give before we actually go and see what an AI bot has to say about it. And so, basically, imagine that you've got a magical basket, and that basket just has an infinite supply of apples, right? You can carry this basket wherever you go, and no matter what, when you reach into it, you can pull out an apple. It's kind of a weird thing, I guess, but just imagine, right? You've got this basket of infinite apples, and somebody says to you, "All right, so when you walk through this door, there's going to be a bunch of different baskets, and in each of those, we'll call them bins or buckets or something, because you already have a magic basket. So behind this door, there's going to be a bunch of different buckets, and each of these buckets is going to have a number written on them, and you need to put as many apples into each bucket as exists, right? Well, if you didn't have a magical basket, you would need to know how many apples you need to take into the room to go put however many you need into each bucket. The while do, or the loop, in this case, in this really bizarre example, would be the basket that you're carrying that has the infinite number of apples, right? As you walk up to the bin and there needs to be 9 apples, you put an apple in, and you look in the bin, you see there's only 1 apple, that's not 9, so you put another one in. You look in the bin, there's 2 apples, which is again not 9, so you just keep putting apples into this bin until you reach the number 9, and then you can proceed. And that's like just another sort of abstract, weird way to think about looping logic, right? It just, you almost, well, not almost, I'm pretty sure you always need to have a counting integer so that you can know how many times the loop is going to run. But you also need to use it to compare, right? And that would be to go back to my really crappy example, the counter would be how many apples exist in that bin, right? You're putting an apple in every time you take an action, right? You put an apple and then you examine it again. And there's only one apple, so you add one. Um, anyway, so basically, now that I've kind of tried to do a really bad job of explaining this, let's see for a second how like ChatGPT might explain something like this, and maybe they'll. I'm assuming they'll be much a lot better about it. All right, so please explain how to write or how loop works in programming. Blah blah blah. You can read. So this may not actually end up being much easier to understand quickly, but if at the end of this video you're still sort of like lost on this, I would say try to go to like an AI, ask it a question similar to what I did, read through it and try to really understand. But basically, let's kind of talk about this quickly. Um, Initialization. Before entering the loop, you typically initialize a counter or set up any necessary variables. This step prepares the loop to start. And so if you've ever seen a while do loop written, you'll notice before the loop, there's usually something like I equals 1 or temp counter or counter equals 1, right? That would be the initialization and setting up the counter. So next there's going to be a condition that controls how long the loop continues to run. And this condition is evaluated before each iteration or each time the loop starts again. In my example before, that would be like the condition would be keep putting apples into this bin until there are 9 apples. So, you take the action, you put 1 apple in, the conditions aren't met. And so you keep performing that action over and over and over until you have 9 apples in the bin, then you can move on with your life. Iteration. Inside the loop, you write the specific actions or tasks, right? Move the apple from your magic basket into the new bin. These could be calculations, printing messages, updating variables, etc. This is where I feel like loops become a little more abstract because I'm talking about like putting apples in a bin, but it could be anything. Loops are very, very flexible and very useful. So then update, step 4, after each iteration, each time you put an apple inside the bin, the loop updates its state in some way. So that would be where we would be adding +1 to our counter, which is what we use to compare against the initial condition. And then last is termination. The loop continues to run as long as the condition specified in step 2 remains true. So while there are less than 9 apples in the bin, do, and then, that would be like the first line in cabinet vision code. And then your block of code would basically be, add apple to bin or whatever, right? There's no dimming apples in cabinet vision. But once you reach 9 apples, then you exit the loop. And generally speaking, once you're done with that, unless you have some sort of reason to maintain your counter at the number that you arrived at, it's kind of a good practice to delete the counter or at least set it back to 1. And so another part of loops that I think probably was so hard for me, at least, is this idea. Like, I thought UCS already run on all the parts, and I thought it already, just like loops, right? Every time you rebuild, all the UCS run again. So how does this really work? But just with some practice and some time, it'll start to make a lot more sense. But for the sake of kind of going back to the initial example that even brought this up, I'm going to go through a very short little exercise of writing one block of code to actually add a route to this door, and then we'll go through what would be required to make this work on any door of any size, which is, what the loop will be. So just a moment. It's still early and I'm drinking my coffee. Apologies. All right, so this is not, I'm not really going to explain simple programming concepts in this video. I am assuming if you're watching this, you already know how to do, how to write fairly simple UCS. I'm going to assume you don't need me to explain what it means to dim a route, or the different names of objects, or really anything. But I will say that if anybody does happen to be in here and has a question, feel free to ask, and I'll do my best to stop and answer it. But as is usually the case, I'm guessing this will probably not be viewed very much until we get to YouTube, which is fine. So gives me a lot of practice talking to myself. This looks weird for some reason. I feel... Oh, I don't know. It's probably fine. I don't really use my home computer for cabinet vision a whole lot, and so it's something about this just didn't quite feel right to me, but we're going to proceed anyway. So well, could really use Tristan's little Sublime setup for this kind of thing. Yeah, so fairly basic, simple start. Just trying to add a dado, and again, sorry, I normally work with version 12, and a lot of the names have changed, so bear with me if I need to make a couple of adjustments to this if it's not working the way I am expecting it to. You need to add a door that has a flat panel. So I'm actually just going to change this to make it easy, because I don't really want to find a door that doesn't have any UCS working on it or anything like that. So, all right, we've got this little 1x1 route appearing on my door. So we know, or dado rather, we know that I've at least typed the right word for it. And lovely thing about the doors that I've noticed, um, you don't really see the route when you're in the part editor, and I'm not sure. I almost wonder. Yeah, not really. So one of the kind of like fun things that if you know the answer to this, great. But basically, while looking at the actual part editor, I feel like you don't get to see the routes that you add through UCS, which can be a little bit um, confusing and frustrating at times. But I mean, whatever. You can check it at the S2M Center, and you can measure it right on the assembly. So, um, so now we've got this sort of. Well, let me make it look a little bit more like what what we were saying. Just a thin little groove, right? Jeez. All right, so just a thin little groove on the door, right? And what they were wondering about. Oh, it's on the back of the door, of course. Man, I am just firing on all cylinders today with this. That route is like on the. Oh, I didn't add a face working plane, of course. There we go. All right, so there's just a groove in the middle of this door, 3/8 of an inch deep, right? And so if you wanted to make this groove appear as many times as you need it across this door, that's one of the places that you're going to want to use a loop. Anytime you have an unknown, like an unknown size that you want repeated operations occurring on, obviously not a line bore, because line bore you can just use repeat, but yeah, anyway, yeah, I'm rambling. So if we just to kind of give an example of a really basic way to do this, if you only had one door that you were going to do this on and you never needed to do this again, so there's no sense in like writing a UCS for it necessarily, that would look something kind of like this. So you got your first groove. All right, now got my second groove, my third groove. Right. Already we're at like 68 lines of code. But right, we're starting to get grooves down this door. Cool, right? So for this one, you just copy paste that the 14, 15, 20 times, whatever it is, and you've got a door that has all your grooves on it, which is great. You send it off, for approval from whoever you're working with, and they're like, that's great. I love that. Except these are too close. Each one of these things is way too close right now. That we need to have 2 inches of space between all of the grooves instead of 1 inch of space. And so then you kind of have to go, back in here. Oh, sorry, I'm kind of thinking about doing it manually. Back in here, and now change all of your x's to, multiples of 2. And then, of course, inevitably, right? Oh, come on. Finicky bastard. All right, so then you send this off. You're like, great. All right, cool. Got it. Done deal. We've got this, no problem. They're going to be satisfied with it. We got the job. And they come back to you and they say, I really thought I liked 2 inches, but I don't. Let's go back to 1. So, of course, now you're wasting your time doing the work again and again, right? So anyway, again, I might be beating a dead horse with this, but I'm trying to explain as best I can certain cases where using a loop will be beneficial to you and where it will save you time. And when you've got like repeating things, I guess, repeating conditions that need to be met, loop is very good for something like that. So how do we actually write this as a loop instead of just repeating that block of code over and over? Well, the first thing we would need to do, and again, I'm just going to say this because it's worth saying every time. Whenever you're writing a UCS, you should always have a condition at the very top of your UCS that prevents your UCS from ruining everybody else's work. And what I mean by that is have a filter of some sort that prevents what you're doing from affecting anybody else's currently open jobs. This is especially important if you're on a network because the changes you make to your user-created standards are more or less instant. If you're on standalone and you pass your databases around, not quite so important as long as you remember. But I can tell you there have been a couple of times that I have forgotten to either put like a filter in place or shut a test UCS off before I distribute our database to the team, and people have ended up with things on their computer wondering what the heck this is, right? So I'm at home and I'm not going to be distributing this to anybody, so I'm pretty safe to not have like a test filter in here, but best practice, right? So I'm going to just put this filter on my job because at this point the grooves are going to go away. Obviously, we don't even have the 1 because my filter is preventing that from happening. So all right, so got my test UCS filter in here. Even if I do give this out to the rest of the team, as long as they don't add this to their job, they're safe, right? And as you can see, it doesn't even have to be true or false because I wrote it as if it's null. So how about this? Now I can actually flip it on and off while I'm in the job. In case I wanted to see what things are like while it's on or off, right? Anyway, all right, so hey, look at that, nice. Again, forgive the pauses. I'm just kind of chilling a little bit this morning, drinking my coffee. All right, so to sort of use what ChatGPT had to say as a guide, we've already established that we're trying to repeat a block of code multiple times. We saw the manual application of it and how cumbersome that can be. So let's go through and actually build a loop. Before entering the loop, you typically initialize a counter or set up any necessary variables. So the types of variables that we might want are going to be groove width, groove depth, groove spacing. If you happen to want to maybe use like different shaped tools for different profiles, then you could put like groove tool ID. I'm not going to do that, but just to kind of give you guys an example, these are the variables you want to initialize before the loop. You need to define these things before the loop because the loop is going to use this information. And so if you don't establish these variables before you write your loop, you're not going to be able to reference them since UCS reads top down. So other than groove width, depth, and spacing, we need a counter, which maybe isn't necessarily a variable needed, but like for the doors, but we do need a counter. So width, depth, spacing, and counter. So I'm going to set the default groove width, dado width, whatever we want to call it, to 1/8 of an inch. So just a short little aside, copying code and pasting it again is a really good and a really bad idea for anybody kind of getting into this. Copying code is wonderful because you don't accidentally typo stuff. Copying code is terrible because it's really easy to forget to change like just one little character, but there's strategies you can use find and replace to switch these out, right? Which I'll do now. Groove spacing. And the way this works is you want to, with the one highlighted, replace it and work your way through it. And when you go up to the beginning, you know you've changed all the ones that you want to change. If you click replace all, it's going to literally replace all of them unless you highlight the selection and then use in selection. But anyway, but even doing that, as you can see, my description of the attribute didn't change. It didn't target that. So again, just if you're going to copy paste code, it's a good idea to just be very thorough. And then the last, well, technically groove depth was one that I needed as well. All right, and then, so those would be the three things that we can use to define the spacing and the depth. And before we even get into writing any loop stuff, I feel like it's a good idea to take these values that we've created and plug them in where they need to go. So the dado dx would be the groove width. The dy being the length of the door is fine. That should probably stay that way. The groove depth would be the dz. And then the groove spacing would be your X position, kind of. We'll keep the depth at 1/8 of an inch. We'll keep the width at 1/8 of an inch, but I'll do the spacing on 1 inch increments. And so depending on whether you want the groove to start right at the edge of the door or in from the edge of the door by your spacing amount will change the way you write this. But I'm going to write this as though I do not want a groove immediately on the edge of the door. So the first groove is going to appear 1 inch in from the edge of this door. And we'll try to write this 2 different ways. One will be done in such a way that you define the spacing, which means you have to control the size of your doors so that your spacing ends up right. And then I will try to write this in such a way that the spacing is like nominal, a nominal 1 inch spacing. And what will happen then is it'll put as many grooves as can fit on the door, maintaining spacing that is no less than 1 inch in between. And that'll be just a different way to write this, basically. But to keep it simple, we've got the values transferred, the parameter values that we've generated, and we've got them in here. Before I write any looping stuff, I just want to make sure that this is working, and it's definitely not. See, this is freaking jacked up. Oh, because I'm a dumbass. Wow. So forgive me for that one. That was a disaster. Only got the X right. Every other one I just kind of derped on. All right, so where are my attributes at? So this is another frustrating-ish thing about doors because they kind of work like assemblies. You have to put your attributes on the door part. And I will just exit after we do all of that. Sorry, had a little need to pause for just a minute, but all right. Anyway, so now if we click on the door, we've got these groove values. Can change the width. It's responding. The depth is responding, and the placement is responding. So just a good idea to test your stuff before you get too far with it, honestly. In general, whenever you're writing a program or coding or modifying, take small bites and never mind the fact that this is obviously a problem going through the hinges. That's not really what we're trying to work on. So, all right, now we're ready to actually get into writing the loop, right? We know we've got this block of code set up in such a way that the dado does get applied. It looks right. It's responding to the values that we've entered. So how do we get this to go for as many times as we need? You have to put it in the context of whatever it is that you're working with. And so step 2 would be condition, right? There's a condition that controls how long the loop continues to run. This condition is evaluated before each iteration or each time the loop starts again. So what is the condition that we're trying to do? We're trying to create here? Well, basically, the condition would be while, rather than trying to say it that way, in layman's terms, right? We want a groove spaced every inch, all the way across this door, and we don't want any grooves that are going to be added off of the door. So, with 24 inches of door, for example, you're going to have like 23-ish grooves or so, if you're not counting the groove width. And so that's sort of the structure of the while ... do line. You're defining that condition. And so to put it in the context of this specifically, we want to say while, well, sorry, I need to initialize the counter. So here's our counter. It's just I. Generally speaking, in programming, I is like the universal variable for the integer counter in a loop, but you can make it whatever you want. I is just short and sweet and easy. So anyway, now that we've got the loop, the counter and the variables, now we'll go to the condition. So the reason you need to define your counter first is your condition, it has to do with the counter, basically. You have to use the counter. And your counter can start at 1 or it can start at 0. It just depends on how you write this. I mean, you could have your counter start at like, 20 and work backwards if you wanted to limit the number of times your loop could potentially work. There's a lot of different ways that you can write them, but in this case, we're just going to start with 1. And again, we're basically trying to say while the spacing of the grooves times the counter is less than the overall width of the door, continue looping. So kind of thinking through how I want to write this. I don't like this where I'm going with it. So what I'm basically saying here, right, is while my counter times my groove spacing is less than my door's width, do repeat this over and over. And as I've said before, loops are not the easiest thing for me, and so I very often fumble my way through them, and that's kind of what we're going to do today. So the condition we've defined, right? While I times ACC groove spacing is less than the door's width, loop over and over. But we don't have anything inside the loop yet that's going to increase the counter of I. And so if I just did end while right here, we'd have an infinite loop, because 1 times 1 will forever be less than the SD slab's width, right? Stack Overflow. That means that your loop went on forever and ever and ever and ever, until you reached the maximum number of loops the Cabinet Vision supports, at which point it overflowed. So that message will help you. Stack Overflow usually means you're, well, I can't say usually, I don't know, I'm so new to programming. In the context of Cabinet Vision, that message containing stack overflow means that your loop was infinite. So you know that something is wrong with your condition, or you're not doing the right things with your counter. But the way that you solve that is within your while do loop section here, after you've done what you want to do over and over, after you've sort of like, after you've written the code block to add the dado, that's when you want to add +1 or 2 or whatever it is to your counter. Now, if you are not explicitly defining I every single time you change it to be an integer, you'll have problems if you switch between imperial and metric. So yeah, define it as integer every time. Or even not switching. If you're metric and you don't define it, you're going to have problems. So just make sure you explicitly define this as an integer every time, and you should be okay. So now that would be, right, the iteration. Inside the loop, you write the specific actions, which is the dim dado, and then update after each iteration, or each time the code inside the loop finishes executing. The code usually updates its state in some way. This could involve incrementing a counter, right? I plus equals 1. So now, while I times groove spacing, or while 1 times 1 is less than the door's width, run the code, then add 1 to I, so that when this little block gets to the end while, it's going to go back up and check again. Is this condition still true? But at that point, I will now be 2 instead of 1, because we've added to it. So the second iteration would basically say, while 2 times 1 is less than the door's width, run the code, and then add 1 to I again. So it gets to the end while, it goes back up and checks again. While 3 times ACC groove spacing is less than the door's width, run the block of code again, so on and so forth, all the way until I times groove spacing would no longer be less than the door's width, at which point it will no longer come up here and perform this action again. Now, where you have this counter adding does matter a little bit, but generally speaking, you want to have it down near the bottom of whatever code you're executing. So again, just to kind of, oops, wrong thing there. So we're updating, we're incrementing a counter, right? And then the termination part of it is really just what we talked about just now, right? It's going to iterate over and over and over and over and over until this statement is no longer true. And on the last time that this isn't true, it will not do this action again. Now, if you wrote this a little bit differently and you had I int plus equals 1 above this part, you could, just depending on how you write the rest of this, you could end up running your loop one more time than you intend to. And so kind of paying attention to where you have this matters. A lot of times you'll run loops to count things, and the loops are much simpler at that point. You're really just saying, you know, if we wanted to count how many of these grooves could fit inside of this door, we wouldn't be dimming the data. We would just say, while I times groove spacing is less than the door, add +1 to I. And then after everything ended, after the loop ran its course, I would be equal to I times groove spacing would be how wide your door is. And so you've sort of like counted the number of inches in the door, if you will. And so when you're counting things, you're usually trying to run the loop until you have a number. Like this door has 6 hinges. I know because I've counted them. That would be when you would do something outside of the while do loop. Hopefully that doesn't confuse too much, but I wanted to just kind of remark on that a little bit because there are a lot of ways that you can sort of use loops, and we're only going over one of them. But anyway, at this point, what we should be seeing, honestly, this should be it. This should be the loop. It should be done if I've written everything correctly. And let's find out. Doesn't look like I've written everything correctly. And that's going to be because I didn't actually do anything with I anywhere in here. So it looks like nothing happened, but what we will find is if we look in the object tree, this door is going to have a bunch of routes, and they're all going to be in the same exact location. Freaking stupid thing. Sorry, I'm used to the object tree, not here. And there we go. Look at all of those dados we got. And every single one of them is in exactly the same location. Right, all the way down. Dado 29. Oh, there's a lot. It might even be more than I was expecting, but well, no, my door's 20. Cabinet's 30 wide, so that's right. So what we need to do here is we actually need to make sure we're using I. And so this is another part of the loops that was a little bit hard for me to sort of understand. And the reason that this was hard for me to get was because it took me a long time to start to grasp the difference between just defining a value using equals or defining a value using colon equals. And so if you don't know the difference between those two things, this is going to be fairly challenging for you. But I will simply say that when you say dado.dx equals ACC groove width, you're saying that once the UCS has completed everything it needs to do, and you're down at the very end of the UCS, ACC groove width is what DX will be at that point in time. Versus when you, and so in this case, right, if we looped through this thing 29 times, at the very end of it, it's still just putting all of the grooves right here. And even if we change this to, sorry, should have been pointing to X. Even if we change ACC groove spacing to be ACC groove spacing times I, because we're just using an equals here, which waits until the UCS has finished running, I'm fairly certain we're still only going to get one groove stacked on top of each other. We might get two. No, there's one groove, and it's all the way over here, and it's pretty screwed up. So that means that the counter went all the way to the end, and now the calculation was done based on I being equal to like 29 for every single route, or groove rather, that was placed. And again, I'll show you that just because I think that it helps. Right, 30. X is 30 on all of these things. And if you look at the equation, you see, right, it's HCZ groove spacing times I. So what's I? I is 30. So yeah, of course it's going to be that. So you get around that in your loop by using colon equals. And so what colon equals does is, rather than allowing this to be calculated as an equation that waits to resolve until the end of the UCS, every time you loop, you are defining the dado.x value at that exact moment. So the first loop, it's going to define dado.x at ACC group spacing times 1. The second iteration, it will define it as ACC group spacing times 2. And because we're using colon equals, it's defining it right now as the loop occurs. This is a concept that was very difficult for me to grasp. So if you're having a hard time with it, reach out on Discord. We can talk through some other examples, especially if you've got something in particular that you're trying to work with. But basically, we're using colon equals here on groove spacing. So you might wonder, why are we not doing that for all of these other fields as well? And the reason for it is we actually are not changing the groove width. We don't ever want the groove width to be anything other than what it is, and we don't ever want the groove depth to be anything other than what it is. In other words, they all need to be the same width. They all need to be the same depth, regardless of which iteration of the loop we are in. So loop 1, the width is 0.125. Loop 2, the width is 0.125. Loop 3, the width is 0.125. We're not trying to change anything, so there's no real reason to force it to occur right now during the loop. Now, one last thing I kind of want to remark on is that when we were looking in the object tree, what I saw was DFP groove about 29 times. And maybe you don't care about them all saying the same thing, but I do. I absolutely hate it when there are things that are named the exact same thing and you cannot tell without examining their parameter values what they are. And so you can actually use your counter in this loop to name every single one of these datas that we're adding by concatenating the value of I onto like data description, and just like that. So now, and again, we have to define it right now. I'm not entirely certain this is going to work out because usually defining strings right now breaks things, and so I might have to do this a little bit differently, but we'll see what happens. The main thing is that we want to see grooves all the way down the door, which we're seeing now. And if we examine the object tree, so now these all just say door slab, which means that I definitely did not get them naming the way I wanted. But again, I kind of expected that. But we do have different datas at least, which is great. So this might be a weird situation where you don't actually need to, yeah. So looping and defining string values, see exception where you don't want to define it as an equation. So just to add to the confusion, right? But as you can see, here, every single one of these is named now, and so we can see pretty easily where every single one of them goes. So now we can test and see, what about the other stuff that we did, right? Do the grooves actually change? And if I increase the spacing, do they just run off the edge of the door? You know, because that would be how this would work if you had a static 29 different grooves coded. You know, if you change the size of your door or the spacing, those grooves are just going to run off of the edge. So if we go to 2-inch spacing, look at that. We have fewer grooves now, and we didn't really even have to change a whole lot about it. And so again, the reason that this kind of works and the reason this is such a powerful concept to understand is you can throw a block of code logic at a variable condition that you can never really know what the final result will be until you get there, and it will handle it every time. The only thing that this doesn't do really is start the spacing and stop the spacing equally, because we didn't build anything for that. I've already been streaming for about an hour, and I don't really want to. I'm trying to keep these under an hour when I do post them, because more than an hour is just like boring to watch. But yeah, so we could add just a little more logic to this to adjust the start of this. If I can get that done in about 5 minutes, I'll do it. Otherwise, if we hit 8 a.m. and I'm still in here, I'm probably just going to end the stream. But I'll try to run through it real quick. So how would we really even kind of like start to do that? Well, you would need to really So basically the math would just be the width of the door divided by the spacing, and then you would take the remainder of that and figure the difference between the remainder and the first position, and that would be where your first dado would start. And if you are defining your start location as a little bit different from your counter, you kind of need to write that, I think at least, a little bit differently. I feel like when I've done something like that in the past, I actually start the first iteration of the loop outside of the loop and then go based on that. But let's see what we can do. So sorry, you get to deal with a little bit of my weird anal stuff for a second here. All right, so what I've done is basically when I initialize the first group location, oh, this isn't gonna work, damn it. This has to be before that. Ugh. OCD does not like. So when first groove is initialized, it's going to set its value at whatever group spacing initializes at. And honestly, because I can, since I know that I'm initializing this at 1, I'm just going to start this out at 1. But, and anyway, so when the attribute gets defined originally, the first groove will be set as 1. And what we kind of need to do here after that is some math. And I'm thinking about this, and I know it's 8 o'clock, but I'm probably going to finish this up anyway. So as I really kind of considered this, I should not really even be initializing this in a way that can be seen by the user, because this is a calculated value unless you want to define it as something specific. And so I would say this would be something that you would not want to give the user control of necessarily. But so I'm setting this up as an attribute so I can watch it while I work through this, because um, it's my way of testing it, right? I know that this value is not right. I'm going to need to do a little bit more to it. But testing it is just how my mind works. It's going to help me. It's going to kind of help me out with that. So group start at 0. Great. That's wonderful. Why is that returning a 0? Oh, that's probably why. Oh, freaking object tree. Crap. Okay. So because the D slab is the child of the door, there. That's kind of an interesting number. The 4688. My math is clearly very wrong on this right now. Come on, brain, work through this. Okay, so that's what I'm getting. So 7 times. It's amazing how the simplest little equations can stump me from time to time. So I might be overdoing this equation a little bit, but so groove starting at 1.875 is actually the remaining distance there. So I'm not considering the width of the last dado. So this should give us 1.75, which should be the very end amount. Okay, so all of this plus groove spacing. So the number that we should be seeing here, if I have done this correctly, will be 5.75 divided by 2. 2.875 if the math is right. Beautiful. All right, so now that we've got this first groove value defined with this stupid equation, what you can do is within the loop, you can say if I do it here. So we're saying if I is equal to 1, which would mean if it's the first loop, the first iteration, then we want to set the groove spacing to actually be first groove. Otherwise, set it to groove spacing times 1. And first groove should be the value that we calculated here, and I'll briefly go through this equation after we demonstrate that this is right. Of course, it only targeted the first one. So then here, what we need to do is plus minus Yeah, still not quite, not really what I was wanting. What am I doing wrong here? Come on. So this would be a good example of where you wouldn't want to initialize with 0, I think. But that means that my first dado is gonna start. All right, there we go. I'm just gonna go ahead and log out. Oh, that's right. Man, I have this right. I just didn't do the rest of it. All right. So in this case, I would need to, because I'm adjusting the start point, I'd have to do a little more logic to control where that last one is going. But anyway, 2.875, 2.875, they're spaced pretty much perfectly. So to handle this last one going off of the door, you would pretty much just need to add a little more logic to make sure that you don't accidentally do that last one. And it might even just be something that could be kind of worked with in the initial while here. But anyway, so hopefully this has been, despite being a little bit rambly, as they tend to be, and despite a few obvious issues working through it, hopefully this will be like a good example for you if you happen to be trying to learn about loops in general. And again, like I said, if you happen to watch this video and you're still not getting it and you just want to ask me a couple of questions about it, hop on the Discord server, send me a message. I will be more than happy to respond and try to help you out with it. So I'm going to spend just a couple minutes real quick explaining this equation for anybody who might not be familiar with this operator right here, modulus. I think I've talked about it before, but just to kind of break this down. So the math on this basically was, right, the width of the door divided by the groove spacing, which gave us like 7 point something. It was 7 and a remainder, right? Which would mean that there were 7 point something spaces. So that means that the point something value, if I wanted to know the actual measurement, I would need to multiply that partial value by the groove width. which is what I've done here, groove spacing, right? So I'm this whole section of the equation before I multiply by the groove spacing, which I said groove width before I misspoke. I meant to say groove spacing, is doing what I'm trying to describe here. So what modulus does is, I'm going to just kind of say 7.482 would be like the resolved equation here, right? The door's width divided by the spacing would be like 7.482. So, which means that a truncated, and so, sorry, kind of getting ahead of myself. Modulus, and then truncating this value, which is just 7.482, takes all of the remaining decimal values away from the 7. So that just ends up being 7.482 modulus 7. So what the modulus operator does is really niche, but it's really cool. It literally just clears, it's like the opposite of trunk, I guess. It's like the opposite of truncating something. Rather than getting rid of all of the partial value, which is the 0.482, that's what truncating did to it. But when we divide a number, well, when we are using the modulus operator, the way that this works out is you divide 7.482 by 7 as many times as it will go in, and then whatever number you're left over with is the result. So 7.482 modulus 7 equals 0.482. And so from there, I was able to just take, 0.482 times ACC groove spacing, which resolved to 1 point is what that ends up being, right? And so then that was essentially the number left over at the end on the right-hand side of the door. And so from there, you just take that and you add it into your groove spacing, which was 4, which gave us, 5.928, and you divide that by 2 here at the end, and that's how you get the placement location of the first groove using the modulus operator. Not really so much to do with looping as it's just a neat math function that I wanted to share. Really don't get to use it very often, but when I do, it's a lot of fun to use. So anyway, I hope this stream has been helpful for you. I'm a bit rusty. I haven't done this in quite a while, so thank you for kind of sticking with me if you did. Or if you're watching the video later, very much appreciate it. Before I go, I do want to remind everybody that our Discord community is growing. It's growing at a pretty good pace, and it is, I'm going to be completely honest, it's much healthier than I ever thought it would be. There's so much engagement from so many people, and if you guys are tired of hearing this from me, let me know. But I am just so grateful for all of the people who are offering their time and who are contributing to building it into what it is. I am so grateful for the attitudes of everybody, the fun we're having. I'm having fun, at least. I hope that you guys are too. There's such great camaraderie there, and I feel like I'm really getting to know some really amazing people, and I'm just very thankful, and I'm very grateful that everybody is showing up. And if you aren't a member of the Discord server, it's completely free. I am kind of doing like a bit of a donation fundraiser right now because while it's free to everybody that joins it, there are some costs associated with running it. And so I'm trying to offset that as much as I can by asking the community for, little donations. But that's not what I'm trying to talk about. What I'm trying to talk about is the fact that it is free. There's no obligations. I'm not expecting anybody to donate or make any sort of payments. And if you're not on there, get on there. Some of the most talented and capable cabinet vision users that exist are on the server and they're sharing freely. I'm learning daily. I can't stress enough what a great thing it has grown into, and um, really would like to see everybody watching this video join the community if you're not, and everybody watching this video who is in the community. Once again, broken record, I'm sorry. Thank you so much for being there. Without you guys, it would not be what it is, and I think it's really important that y'all know that. So thank you guys. I hope everybody has a wonderful Friday or whatever day you happen to be watching this on. And until next time, enjoy.